Hi all, I'm Natasha Freddy Almeida. Today I'll be sharing how artificial intelligence is reshaping search and rescue robotics, particularly how these robots navigate, perceive, and coordinate in disaster environment. What I really want to highlight is just not at the technology, but how these systems are changing according to their emergency responses. Now, search and rescue robots, or SAR, mission faces major challenges when it comes to its timing. Disaster sites are so dangerous, and every second counts. Artificial intelligence has changed this field with the computer vision, deep learning, multi-sensor fusion, AI-powered robots can detect victims in real time and work together with other robots so that they can work efficiently to find the victim and rescue them. And the shift from these kind of manual rescue operations to autonomous rescue operations helps to overcome the traditional problems like lack of GPS and poor visibility and toxic gases, etc. So, critical roles of robotics in disaster responses. SAR missions are one among the most dangerous and time-sensitive emergency operations. Every second matters, just as I said, according to the United Nations INSARAG guidelines. The chances of survival drops shortly after 72-hour golden window. This makes speed the matter of life and death. Robot plays a vital role in these missions. They can work long hours into places that humans cannot enter or too risky for humans. Rescue operations can make faster. The traditional searches often exposes rescuers to zero visibility, toxic air, and collapsed structures. Artificial intelligence has completely changed the SAR operations. The system provides capabilities such as victim detection, multi-sensor perception, real-time mapping, and synchronized multi-robot activities, which helps them to work with other robots together. And together they can improve the efficiency and increase the chances of survivors. Why AI-enabled SAR robots? In disaster areas, rescuers may face many dangers like toxic gases, low visibility, and lack of GPS information. So, using robots helps to reduce these risks, as I said. Next, mitigation of human risks. And another important factor is time. Time is very important when it comes to rescue missions. Manual search methods are often too slow and not accurate enough, especially when the first few critical hours, which will be take or which will bring every victim's life to the on the line. So time is very important. And next one is coordinated intelligence, which means not only just one robot works in a disaster area. So we have to integrate multiple robots so they can work smoothly. These systems share information, coordinates their movements, and make the rescue works more fast and efficient. And when it comes to the advanced perception, AI also gives advanced perception abilities. Even in the dark, dusty environments, CNN-based vision and multi-sensor fusion allows the robots to see clearly and find the victims and map the area in real time. In short, the AI-powered robots helps lives by reducing human risk and by speeding up the rescue mission. Okay. Next comes my research methodology and objectives. This review is built upon analysis of five papers published in between 2020 and 2022, and our scope is organized around three fundamental pillars of SAR robotics, which is perception and navigation and coordination. So, perception is the eyes of robot, focusing on victim identification and environmental sensing. Navigation is how robot localizes itself and explores the unknown areas which they do not have a GPS information. And when it comes to multi-robot coordination strategies, it is defined as multiple robots work together efficiently as a single team. And by examining these areas, we can access the current state of art in operational effectiveness. So the first theme, advanced AI-powered perception systems. In the first paper, that is, the author's name is Cruz and their team members, they built a robot dog that uses a thermal camera and fuses the data with a regular camera. They proved that using deep learning networks into thermal images works over 90% of time to spot victims, uh, which make it more reliable than regular cameras. And when it comes to the next one, that is That is when it comes to the second one, that is risk and their teammates. They focus on UAVs that use AI for look victims in real time while flying, which help them to get accurate information and instantly the rescuers can meet or rescuers can help the victims right away. In the next paper, that is Dan and her and their teammates, uh, they uh, they used mine rescue drones that uses thermal camera images along with the other sensors to detect specific items like human survivors and their any belongings like backpacks and all. And in the last paper, Quirelta and their team, they suggest that the future system should use active visions, meaning the robot should proactively move its camera to get a better view and use collaborative sensing while multiple robots share what they see to build a clear picture for everyone. Next one is navigation and path planning. So robots need to move on their own, especially when it comes to when they can't get a GPS signal in like building, like collapsed building or mine. They use SLAM technique for this, that is simultaneous localization and mapping. So in that team members paper, they shows the best example. Their drone uses a combined lidar and lidar, thermal vision, and motion sensors to build a map and know where it is without GPS. It uses the graph search algorithm. It always explore the edge of the map, ensuring no area is missed in this map. And next comes the Querelta and mm, their team members paper. This paper covers the planning side, explaining that the search path can be planned either centrally, which means one computer tells all robot where to go and all that, or in a distributed way. Each robot make its local decisions. It highlights that the planning for multiple robots is very difficult, often requiring complex optimizations. So in about manuals and their team members paper, they showed that they presented that the leader follower the my bad, the leader robots give instructions so that the other robots follow them. For big disasters, multiple robots must work as a team. This is biggest fear. There is biggest fear that the communication may fail, uh, so that everything will be ruined. So So in Manuel and their team members' paper solve the communication problem brilliantly. They developed a vision-based platooning algorithm for ground robots. The robot uses simple camera to track a QR code on the robot in front of them in to stay information. This means no communication network and there is no communication network and proved to be highly resilient in real world threats. And when it comes to the Quirelta and their team members paper, stresses about for different robots to work together, they must use a common software language, often the robot operating system ROS. This interoperability, uh, this interoperability is essential for coordinating tasks. In Dang's paper, although it is focused on single drone, its achievement is full autonomy, which is completely working on its own. The multi-robot system is just a collection of many reliable, independent agents like this, one working together. Next comes the operational effectiveness matrices. And operational success is measured by how fast, reliably, and tough the system is in a crisis. Cruz and their members' paper, the effectiveness is proved by that by the reliability of the perception system, which has more than 90% accuracy, and the stability of the quadruped robot on the rough ground. That is the dog-leg shaped robot on the rough ground. When it comes to that and their team members' paper, success here is feasibly of full continuous autonomous operation in a difficult real-world underground mine environment has achieved. This drastically reduces the time and human risk. When it and the next comes the manuals paper. Manuals paper. The key effectiveness measure is the system's resilience, because the robot platoon can navigate, adapt, and even replace a lost leader without any communication. It is extremely robust to the chaos of a disaster. And last one is risk and their papers. their team members paper. Effectiveness is about speed. By using AI on fast flying UAVs to locate victims in real time, the system detects human teams faster, which is the most direct way to save more lives. Next, this is the uh, comparative analysis of SAR robot system. To summarize the entire field and our analysis, we can break down unique contributions of each paper. In the closest paper, they proved that thermal cameras combined with the AI are the most reliable to spot victims in dark, smoky disaster zones. And when it comes to tanks, they solved GPS denied problems, which creates a drone that can map and explore an underground mine completely on its own, using specialized sensors and smart exploration paths. In Manuel's paper, they created a ground robot team that can work together perfectly using only a camera, that making the system totally resilient to network failures. And when it comes to risk and their team member, they focused on speed, showing how putting AI on fast-flying UAVs can deliver real-time victim locations to rescuers, instantly saving the critical time. And last one is Quirelta and their team members. Their review provides the big picture rules, which shows that the robots needs a standardized language to coordinate tasks and share information effectively. Now, let's look into the field validation and deployment results. In underground mine operations, Dang and the team members demonstrated full autonomy of aerial robots in GPS-denied environments with complex tunnel networks. Next, in indoor disaster simulation, crews and their team members conducted real-world tests in dark and um, less visible environment, confirming the reliability of thermal detection systems there. For multi-site validation, Manuel and their team tested platoon systems across 5 real disaster locations, proving their operational robustness. In UAV aerial experiments, performed extensive flight tests showing the effective human detection even under varying light and weather conditions. Finally, the benchmark performance by Queralta analyzed the landmark projects such as DARPA Subsea Challenge and LISARS, helping establish performance baselines for SAR robotics. AI-powered rescue robots make disaster responses faster, more accurate, and safer. They can work in dangerous areas without GPS by using smart sensors and self-navigation. Deep learning and teamwork between robots helps find victims more efficiently. However, challenges including managing real-time data and short battery life. Ongoing a system aims to achieve fully autonomous rescue missions worldwide. When you talk about future directions, use AI to combine. You can use AI to combine data from multiple sensors for better detection in tough situations. Improve communication and teamwork between different types of robots. Make robots more energy efficient for longer rescue operations. Enhance quick decision making and cooperation between humans and robots. Develop smart, fully autonomous multi-robot system for real rescue missions. And when I acknowledge that I used AI tools, including ChatGPT, for my language refinement, including spelling, grammar, and for clarity, and all the ideas and contents are entirely on my own. These are the references that I took for this particular topic. There are 5 papers, which is um, which is around taken from 2020 to 2022. And finally, thank you so much for listening to my presentation. Hope you have a nice day, and thank you so much.